Hey YouTube, JP Dillon. This is going to be part 5 of the Sanusi 5500 that was submerged. In our last episode we finally got the amplifier satisfactory and checked the power supplies, and everything seems to check out, but our radio reception sucks. Right now, feeding it directly in, we get some gobbledygook and a complete loss of sensitivity. Right now on the SoundTech I'm putting in 30,000 microvolts, and this is what we're getting. And if I just even decrease it slightly, we go down to 15, 10, 5, 3, it's more or less gone by that point. We've got some bleed through from another station. Let's see if we can get away from that. Yeah, it's picking up like 6 different things. Yeah, it's weird. Of course, I don't have much tunability at all. Trying to find a blank spot here and it's not working. There we go. Well, anyway, terrible sensitivity, and as you can see, lots of junk. So here is the FM board, and we've got what appears to be 4 stages of IF. 3 stages of IF. You've got 1, 2, 3, and then you've got your IC which fires into the detector, and that's a UA 703, or is it a 702? It's supposed to be, well, the schematic says it's a 703. At any rate, we're going to see where the problem is and if we can't deal with it. So, I've got my oscilloscope, and what I'm going to do is we're going to come to the entry point here, which is where the RF comes in from the tuner. And as we see on the scope here, the RF signal is pretty big at 30,000 microvolts. If we increase our sensitivity, that's about what 10.7 megahertz looks like. I can't get any better sweep on it because, well, it's a 20 megahertz oscilloscope, and so we're kind of at the limits of displayability. Anyway, so as I decrease the RF output, you can see it goes down proportionally. So the first thing I'm going to do is I'm going to try to increase the output of the tuner into the IF strip. And what we're going to do is we're going to come over here to these trimmers, and we're just going to peak them all and see if we can get things to come up a little bit. And break the glue off here. That one doesn't do much. Let's go to the next one. A little bit more signal. Let's see if I can make it easier for you guys to see. You can definitely see it get smaller and bigger as I adjust, but it's really kind of at its maximum. And then let's go to the last one here. I can get the little glue busted off. And we get a little bit more out of there. So we've got this huge, pretty big signal coming out of the tuner itself. I'm on a times 10 probe, so that's 100 millivolts peak to peak of signal. That's fairly large, so we know that the tuner's doing okay. So now what we're going to do is we're going to come over here to our ceramic filters and our different IF stages here, and we're going to see where the signal kind of goes away. And let's increase our sensitivity, because right now it's just a blur on the scope. So we're at 500 millivolts per division, and that's after your first IF stage. So what do we say was going in? About 100 millivolts. So now we're at a little over 500 millivolts. Gain factor of 5 is pretty good. So let's go through our ceramic filter. Alright, so that's our 600 millivolts going in. Not a whole lot coming out. Wow, that's a pretty big loss. Let me just turn down the sensitivity again. So coming out of our first ceramic filter, we've only got 50 millivolts. That's a lot of loss. Come on, focus. There we go. Alright, so if we go into our second IF stage, it should be kicking that back up again. Ain't much of anything coming out of there. Wow. So I've got like no signal at the second IF stage. Let's see here. That's going in. No, that's going in. That's what was coming out of the other filter there. So by the time that we're through the second filter, we've got like maybe 20 millivolts of signal. See, these filters are really lossy. That's not good. This second IF stage isn't doing much of anything. It's pretty quiet. Alright, so that's problem number one. Let's see if there's anything at these other filters. Nothing, man. Alright, let's see what happens when we jack up the signal. Let's put a giant signal in here. Okay, so here's input of the first filter, output of the first filter. That's almost 50% loss. That's a lot. Input of the second filter, output of the second filter. Man, oh man, that's just gone. Okay, and there's our input of the second IF stage. Man, oh man, that second IF stage ain't doing nothing. And then of course by the time we get to the second set of filters, there's just nothing there. So we've got this huge loss somewhere in this stage here. This goes away. I've got this terrible loss through the filters. But even with this tiny signal coming out of the filters, this should be amplifying it, and it's not doing anything at all. So let's get a meter and check our voltages on it. And then let's check the surrounding things here. It's not doing much of anything, is it? Alright, so just taking a look at some basic voltages here. On the collector, we got our supply voltage, 10 volts. On the base of the first IF stage, got 2.6, and we got 2. So this transistor is on. On our second stage, we've got 11.5, which is higher. We've got 3.6 on the base, and we've got 0 on the emitter, absolute 0. We should have a 0.6 drop there, and we've got nothing. Now if I check the resistance between the emitter and ground, we see that we've got a kilo ohm there, so it's not like it's shorted to ground. So this transistor for sure is open. Let's check the third stage here, just for grins and giggles. We got 10.4 going in, 3.593 coming out, and 2.912 going in. So this one's on. This has got 0.6 of a volt across it. So definitely this guy, the second IF stage transistor here, this is bad. We need to replace this. Let's take a look at the schematic and see what it really is. I'd just like to take a moment and give a plug to the Hi-Fi engine. This is an incredibly great resource for finding service literature for vintage audio. I'm going to try to hold the camera still here, but they give all these specifications of the units. They've got all the schematics and everything usually. Sometimes they don't. And usually the scans are very high quality, so I would definitely recommend grabbing that. So I'm going to save this and open it, and then we'll take a look at the tuner. Alright, so here's our schematic diagram, and we're looking at TR202, which is a 2SC930. And we can see there that on that emitter where we were getting 0 volts, we were supposed to be getting about 3 volts. And since there's no short there and I'm reading that R210, the 1K to ground, we can be assured that the C204, which shunts it, is not shorted. And then you see it goes through the pair of filters there. So let's see what a 2SC930 is. Alright, according to the Japanese transistor manual, 2SC930 is an RF transistor, 30 volt, 5 milliampere, 250 milliwatt, beta of about 125, and it's at about 300 megahertz. That's pretty fast. They probably want the wide bandwidth for that IF response. So let's see what things I can dig through, and I'm pretty sure I don't have one of those in stock. Let's see what I can dig up. Let's see, just going through things here. Most of what I have is 100 to 150 megahertz, 70 megahertz, 70, 80, 95, bias transistor, thinking not, output transistors, driver transistors, let's see, there's 50 megahertz, and driver transistors, 100 megahertz, I got nothing here, 30 megahertz, nope, and these are all 120 megahertz, damn it. Then I see something in here like a 2SC3200. This is a small signal transistor. Let's see what this is. Yeah, the 2SC3200 ain't going to do it either. Another 100 megahertz device, not wide bandwidth enough. Damn it. Well, here's an old part that's been sitting in inventory. It's a 2SC1675, labeled as an FM oscillator for a Panasonic. Let's see what this looks like. Alright, so the 1675 is a 50 volt, 30 milliampere, 250 milliwatt, at 250 megahertz. This is probably as close as I'm going to get. So let's pop this thing in and see what happens. Alright, so here we are. We've got our 2SC 1675 in there. And pulling the old transistor out, hooking it up to the little Atlas component checker. It says no component detected. So yeah, that's pretty much the defining tale of death. So we're going to go ahead and turn this sucker back on, and we're going to see if there's been any change. I don't know if there's been any change. Let's find out. Alright, so we've got 3. Let's put the meter up here so you guys can see it. Alright, so on our second stage now, we've got 10 volts coming in. We've got 3.59 on the base. and we've got 2876 on the emitter. So that stage is now working. Now, of course, the big question is, what's the RF signal look like? And so let's go ahead and grab our scope probe. And so on the initial stage of IF, with a big fat signal here, we're going to turn this down a little bit, excuse me. We're going to turn that down so we can kind of sort of see it. There we go. So that's coming out of the first IF stage. And coming out of the second IF stage, not very much. Interesting. Still not very much, but better than 0. Because you got to remember we had 0. So maybe we've still got some loss through those filters there. Let's double check and see where I'm at. Of course, it's also helpful to have an actual signal here. And I don't know why this thing keeps tripping out. It just keeps tripping. That's because I'm riding on top of another station again. Yet when I turn the gain down on that, that doesn't do that. Be nice if I could hear that. Let's hook it up to something and see if we can find a blank spot. Alright, now I've got I've found a blank station finally. And we got it hooked up to my amplifier here. That's the tuner output. And there's our 1 kilohertz. And now, when I turn the signal down, it starts to get noisy at about 10 microvolts, which is about what you'd expect. So that's cool. So that tells me that things are working at least. Which is weird, you wouldn't think so. Let's do a dual mode here and see if I can get this up on the screen. Because you've got this huge RF signal at the first stage. Oh, we've got more at the second stage. So it's just I wasn't injecting a signal properly. So if you want to look at the comparison when it's working, if we look at the tiny little signal going in, which is tiny, that's the top one there. After the first stage, it's gone up many-fold. After the second stage, it's gotten even bigger. After the third stage, I have to decrease the sensitivity. After the third stage, we've got a little over a volt peak to peak there. So that's pretty big. That's very big. That's about what we want. So, the tuner appears to be fixed. How awesome is that? Alright, so now that we've got the tuner squared away for the most part, now what we have to do is work on the multiplexer, which is not working. Let's crank up the signal. Still not working. Crank up our pilot. Still not working. Alright, so we have no stereo multiplex whatsoever. And usually, let's see if our signal meter isn't registering either, which is weird. No. Signal adjustment. There's our center channel meter there when I turn that. Yeah, it's on center channel according to the detector. And this one up here, I guess, is our signal meter, which does not register at all no matter how I turn that. Okay. Judging on how this stuff is, I'm just going to start wiggling things here. I don't know where the pots are. Alright, so now we've got the issue of the tuner works great, but no stereo decoding. And if we reach for our scope probe again and look at the output, this is our audio output here. If we get rid of the sine wave, no, maybe that's not the audio output. There's supposed to be a detector output here. There we go. There's our 19 kilohertz pilot, which as I increase the signal size on the generator, we see that it gets bigger and smaller. So we are getting a pilot signal out, although it's a bit tiny. Let's see if we grab our alignment tools here. Forget which one works best for this. Come on out. Let's see if I mess with the detector transformer, if I can get that to enlarge at all. Yeah, it's about as big as it gets there. Come on, stupid ground. Alright, so that is what it is there. No real loose connections per se. So we're getting a nice fat signal out of there. Tuner's working, multiplexer's not. So that's the next thing that we got to figure out, is why don't we have stereo? And that's this board here. And my fear is that they've got these two tank circuits here, this low pass and this 38 19 kilohertz tank circuit combo. And normally these have an oscillator that triggers their on and off, which is usually a preset to one of these potentiometers. Just at first glance, let's turn our signal up and let's turn our pilot all the way up. We're going to do 120%, and we're just going to VR401, memorize the position, and nothing, no change. 403, no change. 402, no change. So we have to do some hardcore troubleshooting on the multiplexer, and that'll be for the next installment. This thing has turned out to be a bit of a hassle, but we did discover the death of the second IF stage, which has now made our tuner usable. I can go all the way down here to about 10 microvolts. It starts to get noisy, and by about 3 microvolts the signal's just gone. So yeah, that's about normal for this machine. That's what I would expect. It has pretty good sensitivity. We just need to figure out why the multiplexer isn't working and why our signal strength meter isn't working. Oh, it is working, it's just sticky. If I tap on it, it will move a little bit. So maybe the meter movement's just injured. If I raise the signal again and tap on it, not too much different. Interesting. Just as a quick check here, let's go to AM and tune something. Yeah, the signal meter does work because it works on AM. So there's something going on with the signal, the meter circuit here, which is interesting. There used to be a pot here. I'm not sure what that's for. But, and there are some parts missing, but that could be a factory thing. So we can check these capacitors here. This, I believe, is your meter driver transistor for your center channel meter. I don't know about this. A signal strength meter. They're just running it through a diode. So it could be that the diode's bad. If we look on the low side of the diode, there's nothing. On the high side of the diode, there's nothing. Nothing there. But yet if I go here, yeah, we've got voltage here on the control transistor for that center channel meter, 4.9 and 4.5. So this is controlling that meter, which made sense because when we adjusted this, the meter swung back and forth. Anyways, we're making progress. It's slowly coming back to life. And if we just turn our volume up here, there's our test signal. Let's do some tuning. Oscillator's off, but who cares?
A broadcast service of City College and the San Diego.
Tuner's pretty sensitive now. Interesting how I've got bleed over though. Very interesting.
Percentage yield, federally insured by NCUA for details.
1910 in New
But it's working.
Artie Shaw, today's portrait in.
So anyway, there's the repair on the tuner. Now we just got to get cracking on the multiplexer. So that'll be the next installment, part 6. Thanks for watching the video. More to come soon.